Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Motion. What we learned now can be represented in graphical form also. So we are basically learning two graphs, that is a distance time graph and a velocity time graph. So first let us see distance time graph. So whether it is velocity time graph or distance time graph, we are taking two parameters. Of this, time is an independent variable. So we always take time in the x-axis, whereas the velocity or distance we are taking are dependent variables. They depend on the time, right? So they are taken on the y-axis. So let's come to distance time graph. In case of distance time graph, we can find out three things from this graphical representation, because we know graphs are very easy to depict. First, we can find out the type of motion the body is showing. Okay, whether it is uniform motion or if it is non-uniform motion or if it is showing is at rest, everything can be seen by the graph. Second, at any point of time, what is the position of a body, that we can find out. Suppose at this time where it is. Okay. Then third, using distance time graph, we can also find out the speed of that body, because we have distance on the y-axis, time on the x-axis. What is speed? Speed is the distance traveled by time. So we can easily find out the speed as well. I am going to show all the three graphs in the same board so that you will be able to understand it together. Okay, depending on the shape you can easily say whether it is what kind of motion it is showing. So first we are calculating a graph where the body is moving at a uniform speed. Okay, so here x-axis what am I taking? Time. Y-axis what am I taking? The distance travelled, S. Okay, so here time is 1, 2, 3, 4, 5, 6. 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours. We are taking in kilometer per hour. Any parameter you can consider. So since it is given in hours, the the distance travelled is given in kilometers. So I am taking maybe starting from 20, 40, 60, 80, 100, 120, 140, 160. Okay. So now the first point is, first hour the vehicle is or the body is at 60. So my first marking is coming here. Then second it is at 80. Third it is at 100. Fourth it is at 120. Fifth it is at 140. Sixth it is at, I am joining, I am going to get a straight line. Since I am not using a scale and a graph paper, slight difference is there, but you can see that it is a straight line, it should not bend, it is a straight line. Okay, so this graph, if it is a straight line making an angle with the x-axis, then it is called the body is at a uniform motion. Now next case, the body is at rest. Again time is taken in the x-axis, y-axis we are taking distance 1, 2, 3, 4, 5, 6. Here 20, 40, 60, 80, 100. So first position 80, second hour also 80, third hour also 80, fourth hour also 80, fifth hour also 80. So the distance is only 80 kilometer. So first hour it is at 80 kilometer, second hour also it is at 80 kilometer. So is it moving? No. So if it is a straight line parallel to the x-axis, then we can say that it is at rest. Now third, non-uniform. In non-uniform, here again 1, 2, 3, 4, 5, 6. This is time. Now the distance, maybe I am taking 30, 60, 90, 120, 150. So first position is 60. Then it is at 70. Then it is at 90. Then it is at 100. Then 5 is 130. Then 6 is 140. So I can say this is going like this. It is not a straight line, but it is a curve. So there are three types of distance time graph. If the body is showing a uniform motion, the graph is a straight line. making an angle with the x-axis. Second, if the body is at rest, it is a straight line parallel to the x-axis. Third, non-uniform motion, it can be any ways. Suppose, imagine after some time, suppose initial weight, this is 90, it is going at 150, then comes to 120, then goes to 140, then comes to 60. So like this, any shape it can acquire. So if it is a curve or if it is not a straight line, then we can call it as a non-uniform motion. So let's see how can we make use of this graph. So first tell me what graph is this? It's a DT graph only. So what is it representing? What type of motion? Yes, it is uniform motion because it's a straight line. Now, any point of time we can find out the position. For example, after 3 hours, where is the position? So you just have to see this 3 hours where it is, that is 100 meter is the distance. Or after 5 hours, where is the position? After 5 hours, the body is at 140 kilometer distance. Okay, so this is again T, this is S. Okay, now second thing I told was we can find out speed from this particular graph, because as I told, speed is equal to distance travelled by time. So here we have distance and time in this graph. So let's see how to calculate the speed. So in order to find out speed, we can take a small portion of this. For example, if I am taking this point A to this point B, this small portion I am considering. Why I am considering here? There is no clear-cut rule for this. You can consider this distance also, or you can consider this also, or you can consider this also. For the time being, I took this. That doesn't mean that you have to always take this. See, why you have the liberty to take any 2 points? Because every 2, the interval is the same. Because it's moving at a constant or uniform motion, right? So we can take any, no difference it makes. Here also 20, here also 20, here also 20. So in this case, suppose this is A to B I am considering. Okay, so this is the initial distance, I take it as S1. Here is the final distance S2. Okay, the same way, initially the time was taken as T1, finally this is taken as T2. So distance travelled at this point is S2 minus S1, right? Whereas the time is T2 minus T1. So if you connect this, this will become a C. So in order to find out this, we are finding out the slope of this graph actually. So S2 minus S1, what is S2? 120 minus 100 upon, what is T2 minus T1? 4 minus 3. So 20 upon 1. So 20 kilometer per hour is the speed of this body. So we found out the distance between S2 to S1 and also T2 and to T. So BC by AC, that is nothing but the slope of the graph. So slope of the DT graph helps us to find out the speed of the body.